I changed my mind again. The thread size is 1.5/8 National Extra Fine. I turned this down to 1.5 inch in diameter, and I am in the process of cutting that 18 pitch thread. And notice there's an undercut here where I can terminate the thread conveniently. I'll just show you a couple passes. Then when I'm done with this, I have to make the nut. I'm making some progress, but it's slow. Now I gotta, as I said, bore that out just a little bit so it goes on. Now I need to make a nut for that, as explained before, and I'm going to make it out of aluminum. I know I'm going to get a criticism for that, but I just want to get done here. And I was going to use this, but there's a lot of machining to do on that. So in fact, I just happened to find this. How fortuitous was that? 2-inch diameter. Now I do have to bore it out, but that'll save a lot of machining. And remember, this thing is only going to be about 5/16 thick. So I'll whack off a piece of that, put it in the lathe, face it, bore it, and thread it. Another day has passed, but I have cut off the aluminum, put it into the 3-jaw, and already bored it out to the correct size, and now I'm ready to thread, and I've got the boring bar and threading tool here, and I'll show you one view of that, but I'm not going to go too much into this. I've shown internal threading so many times. I am now internally threading the aluminum nut. You can see the threading tool here. Note that the compound is turned at 29 and the off to the left. Well, I guess you can't see it. Using a little kerosene. Actually, it's WD-40. Lubricant. I like the fact that this lathe has a clutch. I think it just makes internal threading a little bit easier, and I'm not going to show all of this. When I do an operation like this, I do it very slowly and deliberately because I don't do it that often. And I can see the threading tool coming through the back side as I watch from this direction, and that's how I'm determining when to stop the cut. I think it's ready to go in. I'm not going by any dimensions here. I'm strictly going by the fact that the thread came to a V, or pretty close to a V. And for my purposes here, that's good enough. And yes, it's going on. Let's see if it goes all the way. I'm being very careful not to cause the work to cock a bit in the chuck jaws, which would then prevent me from taking any more passes with the tool, but I think I might be done. I want to take her up almost to the shoulder here. Oh yeah, that's a good fit. And you know, it stopped right there, which might mean there's a little bit of a burr. No, it's going. All right, I just didn't want to force it. I didn't blow it off or clean it. Yeah, it's going to go all the way up to the shoulder. You see the other reason now for an undercut. Not only is it easy to terminate a thread, but you can come up all the way to the shoulder. So an undercut to me is almost mandatory. Now what I'll do is, well, I'll show you what I'm going to do. Instead of talking about it, loosen up this. Now I'm going to back this off just a little bit. See, this side hasn't been faced yet. Just still got saw marks on it. But by doing this, and I know most of you have done this before, something like this, but some of these little steps that I'm showing you, you know, they're not in books, and you just got to learn them by experience. So I wish I would have had somebody to show me some of these things that I just had to learn over the years. Now, snugging up the chuck, you can see without running into the steel piece that I'll change tools real quickly, face that off, put a little chamfer on there. I actually should take one, I'll polish this up because it still looks a little bit bad, but I don't think I'll take a pass of it. I want this wall to be as thick as possible for obvious reasons. Alright, what do you think of that? That went pretty fast. I wasn't going to show this, but you know, I sure changed my mind a lot, don't I? But this is the threading tool that I used a few moments ago, and I don't know where I got it. I really need to move out of the 40s and get myself a carbide boring bar for threading, but I didn't have the moolah to do that. But the point I'm making here is I absolutely love quick change tooling, and I must have a dozen of these different holders. And I need to make a video on that. I don't think I have. But, you know, 30 seconds have lapsed since I set this up. I already got the tool changed. You know, it's already on center. They're just a blessing to have these Sorolla quick change tool post holders. I need to take this down to a certain thickness. I forgot what that was. It was it 9mm or 7mm or something? So I'll do that off camera, and I'll meet you at the bench presently. You know what? You don't really need all of the tools that I have, but it sure is wonderful to have a lot of different layout tools and tools, precision tools in general. But what I've done now, using the Moore and Wright Sheffield, England center finder here, I just laid a line across there, and I have center punched 2 holes, which I will drill now, and they can be blind holes because, again, the purpose of those is to fit the spanner here. And I think I'll drill them. Notice there's 2 sizes. This is a neat tool. Who made that? Armstrong, and they call it the 2-inch size, but this will accommodate different size holes with the step. But I'll drill it for the smaller hole. I have to measure that, but it looks like 1/8 inch, so I go a little bit bigger because all I got to do is bring this up a little bit. There's no forcing it, or the aluminum would give away anyway. Then I have laid out a hole right there and center punched it for the set screw. So I'm thinking that'll probably be a 1032. I want it to be a fine thread because it's rather thin wall here. Also, did you see or did you realize why I use such a fine thread here? First of all, and that's 18 threads per inch is the pitch. It gives you more adjustment, and you wouldn't want a real coarse thread here when you think about it, would you? So that there's different reasons why you would select coarse over fine threads, and I just touched on it there. You can read a book on that, I suppose. So I'll drill those holes and take care of that off camera. The holes are drilled for the spanner. Get in there. Now, one other detail, and I might be wasting my time telling you that, but I told you that when we have a set screw like this, pressing it up against the thread, you need a piece of brass in there, and all the little dials and thumb screws and that on the lathe are made as such, and often those are lost. And then when they are lost, because people don't even realize they're in there, they fall out, and then you bugger up the thread. But here's the way I like to do it, because there isn't much engagement here on this relatively thin wall. So you can take a piece of this brass rod if you want, cut it off into a little short piece, but how are you going to do that? And you're going to drop it, and you're going to lose it, and you're going to be swearing like a fiend. So the way I get around that is to take the sheet brass, and in this case it's a 5/32 punch in my Whitney punch, and I have 6 of these, one with each different size punch, because you'll be swearing again when you got to change these punches all the time. Okay, I personally don't swear, but I understand that many folks do. So then what you're going to end up here with is this tiny little brass disc, and be sure and make 4 of them while you're at it, because you'll be losing 3 of them. And since you have 4 of them, when they drop on the floor, you don't even care. Just sweep them up, and next time you sweep, throw them away. Okay, getting sidetracked here again. So there is one of these tiny little brass, what could be copper, discs at the bottom of this threaded hole, and that serves to lock that in place. See, now it's locked, because that'll just be a gentle fit anyway, and then it'll stay there. Got a drop of oil and everything, of course. Alright, let's move on to the next step. Now, looking at it from this side, taking the straight edge, man, I didn't have any too much space there. That's dragging, so I may take a little bit more off of that. But alright, that's what it looks like from the bottom, and this will allow me that adjustment that I need after assembly. Now I'm done down here. I have to flip it over and worry about the transition piece in the top, and I'm going to try to make that similar to the way that Walter made it in Germany so many years ago. And I did look at the website, and well, let me flip it over and I'll talk about it. Looking at it from this side, and boy, I got a good fit there, and it needed to be a good fit. And see, now it revolves around the axle. So what I need to do now, this will be cut off. I have to determine the amount yet. And then there'll be another piece screwed into this that'll be drilled and tapped and held in with this flathead cap screw. And the top piece will be, well, remember, this is my test plug. So I will use this piece, maybe face that off about where my fingernail is. Then it'll be cut off approximately where you see the red line to washer thickness that will fit into this other recess here. You see that? Are you following what I'm going to do now? And then that'll be more or less permanently fastened in there, tightened down real well, and then the adjustment made on the bottom. So next step then, I believe I'll cut this off and then determine what the dimensions have to be on this piece. I'm not really going to show that, because that's all routine, tedious work. A lot of measuring and cutting and facing and so on. It's 1 hour later, and here is the piece. Countersunk for this 5/16 cap screw. Putting it in this way, you can see that I have just a little bit of slop there. I wanted that. Now it'll collect chips and debris, but I didn't want any interference there. So you can see now that that's going to fit just right. And where's my straight edge here? It's just a little bit below the surface. Now some of you are probably saying, why didn't he make the whole blame thing as one piece with a head on it, kind of like a bolt like this, with this being the head and then the thread on the bottom? Well, for several reasons. First of all, it appears that this is the way that Walters made it. At least I see cap screws in all of the pictures that I've seen, the parts list that people sent me. Secondly, I want to be able to take this out while I'm doing a job or before I'm doing a job. Why? Because in order to center the table, this needs to be swept, and I've shown that in other videos, and it seems like the ones, the American-made ones that have a Morse taper, are easier to do that. But if this is in place, which means that this is in the way, so there are times when I'll probably unscrew this, take this out, sweep it, and then put it back together and continue with my work. So I hope you're following what I'm saying there. Next, I have to do a little calculating here on where to cut off and face this piece. So what I'm going to do here, or what I am doing, is you can see that there is a space down here. So I'm going to use my taper gauge, and why is it that I was 69 years old before I had any taper gauges and knew what they were? But taking the taper gauge and putting it right in here, then I made the little red mark so I could read it. There is, shoot, I need my bifocals. There's 50 thousandths right there. Now that maybe that's a measurement I'm not going to use, but so I know what that is. Now I'm going to assemble here and see what I got to do. It's assembled again. Now this is a 50 thousandths thick gauge block. Boy, look at the condition of that. It's all corroded. That will never ring. With the slot reasonably clean, I'm pushing that up against this piece, taking my marker. Actually, off camera I'm going to put some bluing on here and scribe that rather than this is relatively crude and equally inaccurate because of the thickness of the width, or I should say the width of the red line. But effectively there now, when I take this off, and well, I guess I will take it off. There. Oh, too good a fit. But if you can see, and you probably can't because I can't see it, there is a red mark right there. I'll take this off, out from the bottom, saw off most of it, and face it to that line. But like I said, I'll put a little die on there now and do that more accurately. And then even though this is only semi-accurate the way I'm doing it, the final adjustment will be taken up on the bottom side with that aluminum nut. Is that quite clear? I don't know why I'm showing you this because I already told you how I'm going to do it, but I've got layout die on this and the Joe block is sitting down there, and now I'm going to scribe it. Now I've had this type of scriber, and I've got 3 of them sitting there for 40 years, and I never have used the hooked end except to pry something out, but here's a good application for that. Holding the Joe block like that, I'm going to scribe it. Now I'll go over to the bandsaw and then I'll face that off, and then I also have to drill and tap a hole in there as well to accommodate this 5/16 18 cap screw. See you then. Alrighty, this is what the whole assembly looks like, and this is the part that I just finished. This is now cut off and threaded and counterbored just a little bit to make my life easier, and then it collectively goes together like this. Now off camera I'm going to go ahead and put it together. This isn't final assembly because I have one more coat of gray paint to go on here. I wanted to wait till the last so I don't soil it. Before I put this thing back together for a test fit, I think I will see if these oil galleries are open. Remember, there's 1, 2, 3 holes there. And here's the Zerk. So using the Western Hemisphere's favorite oil can, an Eagle 66 with 20 weight in it. Let me give that a squirt and see what happens. Yeah, see it coming up? You know, I better put my wife's favorite bath towel on the floor here because I got oil dripping. Give her another shot. Can you see that coming out? And yeah, and it's coming out the other two as well. So those are open and free and unclogged. Good. Now I'm spinning on the cast iron table. It's not spinning on the wooden table. And I'm able to adjust this. But I found that to adjust it I really need to have my Allen wrench on the other side. That's a little disappointment for me, so maybe I'll lock that down a little bit better where that cap screw is and change a few plans. But right here, using a straight edge combination square, I got about 10 thousandths here, so even though it looks like there's some interference, this really needs a coat of gray paint too, but I don't believe it's going to get it. So looking at it from the other side, boy, this thing is heavy to move around. But I think when you go up to a 12-inch, the weight about doubles. That's what she looks like on that side. Alright, I'm going to take this off again, and then I'm going to paint it off camera, of course, and then start the final assembly. Thanks for staying with me.